Hello. Let's take a look at managing some cluster members in an eHealth distributed environment. Most of the cluster commands live in the NH bin directory. For me, that's just the default of C eHealth. And if we go there and we do a listing, and we filter it for cluster, we'll see that there are 6 or 8 commands that we're going to be using. Today specifically, we're going to look at the join cluster. We're going to look at list cluster members. We're going to look at remove cluster member, and we're going to look at restore cluster member. I also want to mention that there is both a bat file and a shell script file for each of the commands here on Windows. That's because eHealth was originally written on a Unix format, so the shell files are what we usually use. But on Windows, the batch files actually call the shell files, so we're still using the same behind the scenes process. We're just redirecting it through a Windows executable. Okay, so the first thing we want to do is we want to list our cluster members. And this will tell us who is in the member table locally. Now, there are a couple of different ways we can do this. Actually, let's take a look at usage. So if we do a -H, and we just learn to type. Typing is an important thing. And it'll give us usage, and we'll see some of the arguments that we're going to be using. If we do a -host, it will only display the cluster member information from that host. If we do a cluster, it will display the cluster information from every member in the cluster that we can talk to except the local one. And if we do an all, it should basically list its own table and all the cluster members that it can talk to. So we're going to do an NH list cluster members -all. And we see that we've got only the local machine and that it has a member ID of 0. So what that basically means is that it's not in a cluster at all. And when you join a cluster, a member ID is given to it, and that member ID is propagated throughout the database and updates all of the different tables so that they're associated not only with the element but also with that member ID so that it knows its place in the cluster. Okay, we actually have 2 machines we're going to look at for joining to the cluster, so let's do basically the same command here. List cluster members -all. Excuse me. And again, we see only the local machine, and we see that it's got a member ID of 0. Okay, so let's go back to the first machine, and we're going to go ahead and do a join. So it's going to be NH join and the switch we're going to use is going to be first member because there are no other members to this cluster. And so what we're going to do is we're going to tell this guy he's the first, and it'll update its local table as well as preparing the cluster values in the database. So we're going to do that, and it joins itself, and it'll process. And so it's asking for a cluster password, and this is the first time we've used it, so it's actually setting that password. And just for ease of use, I'll just use cluster. And so now it's starting, and it only has itself to talk to, so it's updating the local database. It only takes a moment. Okay, so now if we go back and we do a list cluster members all, we'll see that there is still only the local machine, but it now has a member ID, which means that it's been joined into a cluster, and that information has been propagated throughout the local database. Okay, so we see that the machine name here, and we're going to take that with us. Now we'll go to the other machine, and we're going to do a join here as well. Okay, so we'll do an NH join cluster, but the arguments will be a little bit different. First, we want to join the cluster that we just created, and the host for that cluster is the one we just worked on. and we want it to be a trusted machine. Otherwise, the other members wouldn't be able to talk to it. And another argument that's mandatory is use standard EAC. And that basically tells it to just use the profile that is standard rather than a custom profile. And we could say no, in which case it would just use a custom profile. But we go with default of yes, so that they're all uniform. Now another switch I'm going to add here is -V, which will give us a verbose output so that we have a little more information while the join and whatever else is going on behind the scenes, rather than just have 1 or 2 lines of data. It'll spit out a more verbose update of what's going on. And then the last thing we want to talk about is if this was Unix, the -ID would be required. You have to assign one manually. It doesn't really matter what number as long as it's unique to the cluster. But on Windows, it'll do it automatically. And we noticed that on the other machine when we went and did our list after joining, that it now had a member ID. So in this case, we won't use it because we are on Windows. So we're going to join the cluster. We're going to join the cluster that belongs to U159.189. We'll be trusted. We'll use the standard profile, and we're going to do verbose. And verbose really, like I say, just puts a little more information here on the screen so we can see what's going on behind the scenes. And now it wants the password. And remember that was cluster. And there really isn't a lot more information, but there is a little bit more. You notice on the other side it was only updating local database, and here we have a couple more lines of information. The cluster members speak to each other on ports 5050, 5051, 5052, 5053, 5054, and 5055. Those ports need to be open for bi-directional communication because the members do talk to each other as well as all other members in their cluster. So this is finished, and now if we hit our up arrow and we do a list cluster members all, we'll see it's a little different. So first it queries itself locally, and locally it sees itself and the other cluster member that it joined. Then it calls the other cluster members, and we see that here, and then it lists itself locally, and then it lists the remote machine, which is this. Okay, so now we have a cluster with 2 members, and if we go back to the first member, and we see that when we did a list, it only listed itself. Now if we do a list cluster members all, we'll see the same information. It queries itself locally, and we see both machines. Then it queries the remote machine, and then we see both machines. So we have successfully created a cluster. Now, some of the other commands that we talked about was the NHRemove cluster member and the NHRestore cluster member. So a lot of times when somebody's doing an upgrade or something like that, they'll inadvertently use the remove cluster member, and that's not always necessary. The only time you would remove a cluster member is if you decided to use one less polar. The hardware is simply dead, and when the machine comes back up, it'll have a new name and IP. Or you're just modifying the environment of it, and you want to get rid of a machine for whatever the reason is. And then once it's removed, it's only removed by switching a flag in the database that tells us this is no longer an active cluster member, don't talk to them anymore. But that information remains in the database forever and can never be removed. So let me give you an example of that. Let's do an NHRemove. And that's a camel case, so. And we'll get a -H for usage. And we see the options. So the options that are relevant are the host removes the specified file system from the member table of the email system of the eHealth system host name. This is required. Okay, so if I just wanted to update one cluster table, I'd use host. If I did cluster, it would update all members of the cluster except itself. And if I do all eHealth systems in the cluster are affected. Okay, and then we have to do either the ID, which is the machine ID, or the name so that it knows what it's removing. Okay, and then the other switches aren't really relevant to our discussion. So we're going to do remove all name, and we're going to use the name of the remote system, actually. No, we'll remove ourselves. Well, it was the first member. We'll remove the remote system. Okay, so we'll do nh remove dash all dash name, and the remote system was 159.273. Okay, and we'll actually use a dash V switch so we can see what's going on. And there wasn't much to that. It was pretty quick. It sent a message out to all the members and said it's removed. So now if we do a list cluster members all, we'll only see one system, the local system, because we removed the remote system. It still has a member ID and it's alone. But remember that I mentioned that it doesn't actually take it out of the database. And if we use the include removed switch, we'll see now we've got both machines are listed, and under the removed column we see that the remote machine is listed as yes, it's been removed. So again, that verifies that the flag is simply switched to inactive or removed, but it remains in the database. The machine ID is there, and that machine ID is propagated throughout the table and really can never be removed from the database. And so that's why when you remove it, all you're doing is flagging it as removed. You can't really remove it from the database because the changes of adding it to the database are so profound to the database that they can't be undone. Okay, so now if we wanted to put this machine back, we would use restore rather than join again. Because when you join, it gives it a unique name, and we've already joined it, so it would get an error of duplicate row. So our usage here is going to be almost identical. We've got the host, cluster, or all, and then we've got the name of the system that you're restoring. Okay, so what we'll do is we'll do restore all members, and the name was and now if we go back and do our list without the include removed, and we see that it's now back and it's trusted. And if we do the include removed, we see that neither one of them is removed. It shows the value of no. Okay, so those are some of the really important switches, is the NH join, and then the list, and the remove, and the restore. So just take a quick peek at some of the other commands that are in here. We have the set cluster password, and if you needed to change the password, you could do that using that command. And let's say that we had a problem where we had corrupted the local table in our cluster table of the database, and we needed to fix that. What we could do is we could talk to one of the other cluster members and tell it to update the cluster table locally by pulling it from one of the other members. And that's pretty much the only other command here that you're going to use. The update cluster table is the one we just discussed, and the NH upgrade cluster is something you very seldom have to use, because nowadays when you do the upgrade, it upgrades the cluster in the process. So that covers some of the management of cluster members in a distributed eHealth environment. I hope it was helpful.